Okay, we're going to do the principal-agent model in two states. This is going to do the algebra of the model, and then the Excel homework will do the graphical approach more. Let's describe the setup. There are two possible output levels. QL is the low output, QH is the high output. The agent takes costly effort. Low effort is 0. High effort is E. E is bigger than 0. The probability of low output is P, and P depends on the effort level. So when you take low output, it is more likely that you get, when you take low effort, it's more likely you will get low output, or alternatively, when you take high effort, it's more likely that you will get high output. Payments can be contingent on output because output is verifiable, so we will let WL be the payment from the principal to the agent when output is QL. WH is the payment from the principal to the agent when output is QH. Now we're going to talk about the agent's preferences. The agent has a von Neumann-Morgenstern utility function U over payments. It's strictly concave, so the agent is risk-averse. When low effort is chosen, expected utility is the probability of low output times the utility of the payment when there is low output, plus the probability of high output times the utility of the payment when there is high output. When there is high effort, the expected utility is this part is similar in format to the previous one, except now the probabilities are given by P of E, but now we also subtract off the disutility of effort, which is measured in utility terms. The agent has an alternative job that they could do if not doing this work. So if the agent doesn't earn enough, the agent will go elsewhere. The alternative is valued in utility terms to keep the modeling simple, and U bar denotes the utility of the outside option. The principal is assumed to be risk neutral. This is partly to keep the model simple, but it also is to make it more like the insurance case. This means that absent incentive reasons, the principal should absorb the risk from the agent. The principal's goal is to maximize expected output net of expected payment to the agent, and this is the expected profit for the principal. It's the expected output net of the expected payments. So we're going to analyze two cases. One is a low effort solution, and then one is with the higher effort. The principal chooses the payments WL and WH to maximize its objective, subject to the constraint that the agent earns at least as much as the outside option. This constraint is referred to as the individual rationality, or IR constraint. Because the principal is risk neutral and the agent is risk averse, the solution is for the principal to absorb all the risks. So WL and WH are the same, and they are given by the certainty equivalent of the outside option. So that means the principal's expected payoff is the expected output net that certainty equivalent payment. Let's now look at high effort solution. The high effort problem is a little bit harder to analyze, and it's really the heart of the principal agent model. Again, the principal is going to choose the payments WL and WH. The objective function is the same, except now the probability weights are determined by high effort. There is an individual rationality constraint for the agent when taking high effort. The probability weights, again, are based on high effort, and then you have to subtract off the disutility of effort. And here is the new constraint. This is called the incentive compatibility constraint, and it says taking effort is better for the agent than not taking effort, or at least as good as not taking effort. So you incur this disutility of effort, so that's a bad, but you get a higher expected utility because you are taking effort. That's a good. This is called an incentive compatibility IC constraint. It is what's necessary to get the agent to take costly effort. You can rewrite the incentive compatibility constraint. We can subtract off U of WH from both sides, and when we do that, what we have left is this. So this is algebra by subtracting off U of WH from both sides. And then you can bring the E over to this side and bring the minus P0 U of WH minus U of L over to the other side, and what you get is this. So this is the same as the incentive compatibility constraint. It's just a rewrite. P0 is bigger than PE. E is positive. So that means U of WH has to be bigger than U of WL. And of course that implies that WH is bigger than WL. So for incentive compatibility, the agent gets more in the high output state. The agent bears some risk as a consequence. We're going to now characterize the high effort solution, and the claim is that at the optimum both the individual rationality and the incentive compatibility constraints bind. We're going to think this through. Look at the first case where neither constraint binds. Then you can lower WL, the payment in the low output state, by a little bit. That strengthens incentive compatibility, so the agent will still take effort. And if the reduction is small enough, then IR still holds. But now you've lowered expected payment to the agent, and you've satisfied both constraints, so the original solution was not optimal. That handles case 1. Case 2, the IC constraint binds, but the IR does not bind. This turns out the same argument as in the previous case works. A small reduction in WL continues to satisfy both constraints and improves matters, so the original was not optimal. Now we're going to look at the last case where the individual rationality constraint binds, but the IC incentive compatibility constraint does not bind. We're going to look at a different way to make things better. We're going to reduce WH by a little bit and increase WL just so the IR constraint binds. This is a risk reduction for the agent, and so the expected payment goes down, which makes the principal happier. And as long as this is a small enough change, IC continues to hold. So again, that improves over the previous situation, which means the previous situation couldn't have been optimal. So we now have at the optimum both constraints bind, and that is it. So now we can draw our conclusions. First, WL has to be less than that certainty equivalent of the outside option, because if WL was equal to or greater than this, then by not taking high effort, the principal actually could do better than the outside option, but we said the principal just does as well, the agent could do better than the outside option, that the agent does just as well as the outside option, so this must be true. And then this is the other part that's kind of important. The expected payment to the agent exceeds the certainty equivalent of the outside option plus the effort cost. So the principal is compensating for the outside option and the cost of effort, and because the agent bears some risk, this expected payment is bigger than this. This inequality holds because the agent is bearing some risk. The solution to the high effort case is the solution to the overall problem if taking effort makes expected output much bigger. That's this double inequality, much bigger. And when doing so, gives non-negative expected profits for the principal. Now, I have a little graphical demonstration. Let me see if I can get that. And so I'm going to see if I can move this Excel here. Let's explain the graph. This is the low payment in the low output state. This is the payment in the high output state. The 45-degree line is where the payments are the same. This blue indifference curve is the indifference curve that gives satisfaction equal to the outside option when taking low effort. This is an ISO expenditure line at low effort, and its tangent, let's ignore that point, it's tangent at the certainty point. This is an indifference curve for the high effort case where the indifference is to the outside option after taking effort. And now we have this control here to show the ISO expenditure in the high effort case. And I'm going to keep on raising this. And what's happening, so we're just going to identify where the optimum is. By the way, the last thing I should identify is this black dashed line is the incentive constraint, and you have to be on or to the left of that to satisfy the incentive constraint. So now we're getting to expenditure for high effort. Again, don't click on that point, but this does not satisfy the incentive constraint. In fact, you have to go all the way up to here, so the principal is paying a lot more to get the effort, but if the effort's sufficiently productive, then it's worth it. In the Excel homework, this graph will be explained fully, so if you don't quite get it here, you should get it from the Excel homework.